Good morning students, I am Dr.I.JANNATHUL FIRTHOUSE, Assistant Professor of Mathematics, A.D.M. College for Women, Autonomous NAGAPATTINAM. Now I am going to take the topic Graphical Solution Method in Operations Research. Okay, first of all we have to see the question. Maximize z equal to 3x1 plus 4x2 subject to the constraints 4x1 plus 2x2 less than or equal to 80, 2x1 plus 5x2 less than or equal to 180, x1 comma x2 greater than or equal to 0. So now what the type 1? This method is method 1 or type 1 because the subject to the constraint, the two constraints are less than or equal to type. So what is the solution? First of so you have 4x1 plus 2x2 equal to 80, equation 1. You have to convert the less than or equal to equality sign. Then 2x1 plus 5x2 is equal to 180, equation 2. Equation 1 implies, so 4x1 plus 2x2 is equal to 80. In this type, in this model, first we put x1 is equal to 0. Let us take, put x1 is equal to 0. So what we get? So 4 into 0 plus 2x2 equal to 80. So 2x2 is equal to 80, x2 equal to 80 divided by 2, x2 is equal to 40. So what is the point we get? x1 comma x2. So 0 comma 40 is the first pair of points. Next in this equation 1, now we put x2 is equal to 0. So what is the equation 1? 4x1 plus 2x2 is equal to 80. Put x2 equal to 0. So x2 equal to 0, what we get? 4x1 is equal to 80. So x1 is equal to 80 divided by 4, x1 is equal to 20. So 20 comma 0. 20 comma 0. So in equation 1 we are getting two set of points, two pair of points. What? 0 comma 40 and 20 comma 0 is the two pair of points in equation 1. In the same procedure we follow the next equation. What is the next equation? 2x1 plus 5x2 is equal to 180, equation 2. In the same procedure, put x1 is equal to 0. In the same way, we are finding the equation 1. So, put x1 equal to 0. Put x1 is equal to 0. What we are getting? So, 5x2 is equal to 180. So, x2 equal to 180 divided by 5. So, x2 equal to 36. So, what is the point? Yes, x1 comma x2, that is 0 comma 36. So, first pair of points of equation 2. And what is the equation? Put x2 is equal to 0. So what we are getting? 2x1 equal to 180, x1 equal to 180 by 2, x1 equal to 90. So 90 comma 0. 90 comma 0. So pair of points for equation 2, 0 comma 36 and 90 comma 0 for equation 2. For equation, this is for equation 1, This is for equation 2. This is for equation 1. For equation 1, we are getting 2 pair of points, and equation 2, we are getting 2 pair of points. That is the 4 set of points we are having. So now we plot the graph. Okay, so we use the graph paper or else in this notebook. What else? Whatever it may be. Okay. Now we plot the graph. So what is the point we are hearing? 10, 20, 30, 40, 50, 60, 70, 80, 90. 10, 20, 30, 40, 50, 60, 70, 80 and 90. So no need to in the minus side, we are having only the positive points. Okay, no need to draw negative sides. So what is the first point? 0, 40. So 0 in the x-axis and 40 in the, this is the x1 and this is x2. So 0, 40. Next 20, 0. So 20 in the x1 axis and 0. So this is the first equation. So equation number 1. Or else we write the equation here, because avoid the confusion. Next point 0, 36. So 0 here. What is the 36? Here. 90, 0. So now we are going to plot the bounded area. What is the bounded? What is mean by bounded or boundaries? So all region inside the area is the bounded area. So what is the place inside? That is the bounded region. This is the bounded area. So what are the boundaries of bounded area? What are the boundaries? Here the boundaries are the edges, that is 0, 0. Next 20, 0, this one. Next this point, that is 0, 36, and here this is also the boundaries of this bounded place. So we don't know what is the point here, question mark. So we put the name here C. So to find C, to find the C here. Now we are going to find C, because the C is also the one of the boundaries of the bounded area. So there are 4 boundaries for the bounded area. What is the 4 boundaries? 0, 0, 20, 0, 0, 36, and now the 4th point is the intersecting point of this 2 equation. This the equation number 1 and equation number 2. Intersecting point is also the one of the boundaries of the bounded region. So to find C, so equation 1, 4x1 plus 2x2 is equal to 80. 2x1 plus 5x2 is equal to 180. Now we are going to eliminate the equation 1 and 2. So now we multiply equation 2 into 2, that is 4x1 plus 10x2 equal to 360, 4x1 plus 2x2 equal to 80. So you have to change the sign, 4x plus 4x1 minus. Now 10x2 minus 2x2 is a 8x2 is equal to 280. 280. So x2 is equal to 280 by 8, that is x2 is equal to 8 3s are 24, balance 4, 8 5s are 40, that is x2 is equal to 35. So now we substitute either equation 1 or equation 2. Substitute in equation 1. What is the equation 1? 4x1 plus 2x2 is equal to 80. So 4x1 plus 2 into 35 equal to 80. So 4x1 plus 70 is equal to 80. So 4x1 is equal to 80 minus 70. So 4x1 is equal to 10. x1 is equal to 10 by 4. So x1 is equal to 5 by 2, that is x1 is equal to 2.5. That is the fourth point of the bounded area, that is x1 comma x2, 2.5 comma 35. 2.5 comma 35 is the fourth point. Now we find the maximum point, maximize. So what is the point and the equation? Maximize z is equal to 3x1 plus 4x2. Now we are going to substitute these points in this equation. So maximize z is equal to 3 into 0 plus 4 into 0 is equal to 0. Next, maximize z is equal to 3 into 20 plus 4 into 0, 60. Maximize is equal to 3 into 0 plus 4 into 36. 144. So maximize z is equal to 3 into 2.5 plus 4 into 35. 15, 1, 3, 2, 6, 7.5 plus 140. That is the 147.5 maximize z. So which one is the maximum? Answer is 0, 60, 144 and 147.5. So which one is the maximum point along these four numbers? So 147.5 is the maximum. 147.5 is the maximum. So the maximize z is equal to 147.5. Here x1 is equal to 2.5 and x2 is equal to 35. Now we are going to see another one example of this same method. Now we are going to see another one example of the graphical solution method. So what is the solution? Question, what is the question? Maximize z is equal to 3x1 plus 2x2, subject to the constraint is minus 2x1 plus x2 less than or equal to 1, x1 less than or equal to 2, x1 plus x2 less than or equal to 3. Solution. So minus 2x1 plus x2 is equal to 1. x1 is equal to 2. x1 plus x2 is equal to 3. So here put x1 equal to 0. So x1 equal to 0, what we are getting? x2 equal to 1, that is the 0 comma 1. So minus 2x1 plus x2 equal to 1, put x2 equal to 0. So minus 2x1 equal to 1, x1 equal to minus 1 by 2, that is x1 equal to minus 0.5 minus 0.5 comma 0. So next point, x1 is equal to 2. So x1 is equal to 2, obviously x2 is equal to 0. That is understandable because there is no equation. Here only the point x1 is equal to 2, that is x2 equal to 0, that is 2 comma 0. Only one set of pair of points for this equation 2. For equation 1 we are getting two pair of points 0 comma 1 and minus 0.5 comma 0 for equation 1. This is equation 2 and this is the equation 3. Put x1 equal to 0, that is x2 equal to 3, that is 0 comma 3. Put x2 equal to 0, that is x1 equal to 3, that is 3 comma 0. This is the another set of pair of points for equation 3. This is 0 comma 3 and 3 comma 0 is the another pair of points for equation 3. Okay. So that is what is the pair of points 0 comma 1 and minus 0.5 comma 0, 0 comma that is 2 comma 0, another one is 0 comma 3 and 3 comma 0. So now we are going to make a graph, plot the graph. Okay, here x-axis, x1 axis and x2 axis, x1, x2, here x2 dash, x1 dash, here x2 dash. So, what is the graph here? What is the point? 0 comma 1. That is 0 comma 1 here and minus 0.5 comma 0. That is 0.5 here. So, for equation 1. So, you for equation 1. Next, we are having only one set of points, that is 2 comma 0. So, we are having only a straight line 2 comma 0 here for equation 2. Another one is the equation 3, 0 comma 3 and 3 comma 0. So, 0 comma 3, 3 comma 0. So, 1, 2, 3. So, where is the bounded area? So, all the region inside the region. So, this is the bounded area. So, what are the boundaries? What is the boundary point? This is 0 comma 0 is obviously, and 2 comma 0. Next boundary point is 1 comma 0 comma 1 here and here, two intersecting lines. So, equation 1 and equation 3. Intersecting point and equation 2 and equation 3. So, now we are going to solve the equations and find the solution for point C and point D. This is the C and D. Now, we are going to find equation C and equation D. So, in equation C, what two equations are intersecting? Equation 1 and equation 3. So, equation 1 is minus 2x1 plus x2 is equal to 1. Equation 3, x1 plus x2 is equal to 3. So, equation 1, equation 3. So, to find C, to find D, to find this place. So equation 2 and equation 3. Equation 2, x1 is equal to 2, x1 plus x2 is equal to 3. Equation 2, equation 3. So now we are going to solve equation 1 and 3. So you have to eliminate. So you have to subtract 1 and 3, that is you have to change the sign. So x2 plus x2 minus x2 getting cancelled. So minus 2x1 minus x1 minus 3x1 is equal to minus 2. That is minus minus getting cancelled. X1 is equal to 2 by 3. That is x1 is equal to 0.667. You have to substitute in equation 3. x1 plus x2 is equal to 3. So 2 by 3 plus x2 is equal to 3. x2 equal to 3 minus 2 by 3. x2 is equal to 9 minus by 3. x2 equal to 7 by 3. So x1 2 by 3, x2 7 by 3. That is the point of C. So now we are going to find the equation D. In equation D, x1 is equal to 2. So you have to substitute 2 plus x2 is equal to 3. So x2 equal to 3 minus 2. So x2 equal to 1. That is 2 comma 1. That is the point of equation D. So we are finding, we have to find the equation C and equation D. So we are getting two answers. For equation C, 2 by 3 and 7 by 3. For equation D, 2 comma 1. So these are the boundary point of this bounded shaded area. So what is the points? 0 comma 0, 2 comma 0, 1 comma 0, 2 by 3 comma 7 by 3 and 2 comma 1. So these are the points, and maximize z is equal to 3x1 plus 2x2. So we have to substitute these points in maximize z and finding the maximum points. So now we have to substitute 3 into 0 plus 2 into 0 is equal to 0. 3 into 2 plus 2 into 0, 6. 3 into 0 plus 2 into 1, 2. 3 into 2 by 3 plus 2 into 7 by 3. So 3 getting cancelled. 2 plus 14 by 3, that is 6. 6 plus 14 by 3, that is 20 by 3. 3 8 3 7s are 3 3 5 3 6 are 18. 6.2 6.6 and 3 into 2 plus 2 into 1, that is 6 plus 2, that is 8. So 8. So maximize z is equal to 3x1 plus 2x2 and maximize point is 8. Comparing to this point, 0, 6, 2, 6.6 and 8. So which one is the maximum? 8 is the maximum. So maximize z is equal to 8. Here x1 is equal to 2, x2 is equal to 1. x2 is equal to 2 and x1 is equal to 1. So I hope you all understand the graphical solution method of type 1. I hope all you enjoying this video. Thank you, girls.